to the session on IEB, AP, and technical maths with the sharp ELW 506 team, which we have a huge range of things that we can do. And I went through specifically the AP and technical maths syllabus. A lot of it, there is quite a bit of overlap, which is why we pair the two of them together. And this is the plan for us to cover this evening. So the 506 has 640 functions. It has been upgraded, as you can see, by its new look and design. It's got new features like the multiplication feature, which we don't actually use in high school, not even in AP grade 12, as I was seeing. But we do use it in varsity, which is really nice. It's got super, both the sum and the multiplication feature. You've got the lowest, highest common factor and lowest common multiple as well. So there's many different levels that we can use this calculator for. So this sheet here is a whole bunch of links, and what I will do at the end of the, what I'll do at the end of the workshop is give this to you in a PDF. Oopsie daisy, I'm having a day. Is give this to you in a PDF in the chat function so that you can click on any of these links. Now, I was gifted by the very kind people at the answer series, the IEB AP Maths textbooks, which I'm really excited about. So once I've had a bit of time, I'm going to try and add some AP calculus worksheets as well to our Maths at Sharp link here as well. Then, of course, the simulator you can download for the calculator we're going to be using. And then some other relevant things. There's a support group on Zabuza. So if you're looking for some help there, otherwise you can join the Telegram groups as well. They're quite big and you do get spammed occasionally, which is why we created the groups on Zabuza. And then, of course, a link to our YouTube channel. And then if you want to download the Sharp graphical calculator, so you can just use it on your PC instead of having to purchase a calculator. What was also mentioned to me a week ago or 2 weeks ago in Cape Town actually was desmos.com, which is apparently also a really nice app for both smartphone and PC, which does graphing. And apparently it's really easy and straightforward to use. So it's definitely something to take a look at as well. Okay. So just some quick basics here in case you haven't met this calculator yet before. Your on button, your second function button, which activates any of your orange functions, and we'll work through some of that stuff. You've got your alpha button, which activates your blue keys, so your statistics. And then we've got mode, which changes the various modes, and I'll talk through those after this. And then BS is for backspace to delete something. Then, of course, change will just change the way that your answer looks, and equals for getting the answer, obviously. Now, you actually have 9 different modes because we start counting from 0. So 9 different modes on your calculator. So normal is where we will do most of the basic math stuff. We'll do trigonometry in there. There's a shortcut, a really nice shortcut for trig. Then, of course, you've got stats. We've got a table, and I'll talk through doing a present value annuity using your table. We've got complex numbers, and we'll talk through those as well. We've got an equation solver, and I'll work through that with you briefly. Then, of course, we have the matrix, which I'll cover for the AP Maths guys. Then vectors, not really relevant unless you're doing physics as well. Distribution is very advanced statistics. In fact, I don't even think we use them in AP Maths, but I'll take a look once I've had more time and put together a statistics webinar for that. And then, of course, our drill function for the grade 8 and 9 students, which is also available on our 535 and S25 junior quiz calculator as well. So just some quick new functions for you. The highest common factor and lowest common multiple can easily be found on your calculator, which is great. So here's my calculator. If I'm looking for the highest common factor of 12 and 18, I'm just doing a very basic example, then I would say second function and 2 for GCD, which is greatest common divisor, same as highest common factor. And then you can say 18 and equals, and that will give it to you there. So that's just really nice for a quick check. And then, of course, you can do it with as many numbers as you like. So you don't just have to stop at 2. You can put in whatever you like there as well. Now we can also do this with the LCM. So your second function and 3 will give you LCM, and we can just press 18. And again, as many numbers as you need to do. So this is a nice LCM is your same as LCD. So if you are teaching algebraic fractions, we can talk through how do we get the lowest common denominator, and we find the factors that go into all of them, and that multiply out as well. So here's all the steps for you. So let's talk trigonometry quickly. So I just want to show you some nice shortcuts quickly. So the first one is on your calculator, you have these D1, D2, D3 keys, okay? And they're just your shortcut keys. They allow you to save functions that are already on the calculator. You cannot create a new function or a new equation. So it's not programmable. It's not graphical, so it is allowed in terms of the IEB exams. However, for the DBE, they don't allow it in pure maths, just as a side note. Okay, so you can store it into your D1 function button, and then you can say second function sine, sorry, or second function cos, or second function tan. And now when you press the D1 key, it will give you the inverse of sine or arc sine. And then you can just type in your ratio to get your angle. So D, for those doing grade 10 maths, D for degrees. So you save the inverse, and that will give you your answer in degrees Celsius. The other nice shortcut that we have is a Pythagoras shortcut. So I'm going to draw a picture here, and you'll see that we have a point P, and I'll just call my points. I'm just going to make up one because I'm tired of Pythagorean triples. Let's call it 7 and 11 for fun. So what you would do is on your calculator, you're going to press 7, and then above your change button is a button that says X, Y in brackets. And that just gives you a coordinate separator. We use it as well in random function or inputting linear regression data where you have a coordinate pair. So that's what that one is for. And then we would type in a y value, and we would press second function and 8 for r theta, and we get 13, 0.04 if we're rounding off, which would be our hypotenuse. And then, of course, the angle, which is 57,52. Now, this also becomes relevant when we talk about complex numbers and conversions between the two, between polar and rectangular coordinates, which is exactly the same thing that we just did here. But it is nice to see the application for that. What's also really nice for teaching trigonometry and for teaching the class diagram is your table mode. So what you can do is in your calculator, we can go to mode and to the table, and we're just going to put in a basic graph. Now, I've already done the sine function one, which you'll see on the next page. So I'm actually going to do cos, and RCL makes an X for you, and then you would press equals, and let's ignore function 2 for now and press equals. Let's make our step, our start negative 180. So you need to use the negative button and not the minus sign, just because the minus is a function sign and negative is a value sign. And then, of course, if you wanted to, you could do it in steps of 1. It would just take you a very long time to get through anything relevant. So we're going to just make our step 15 and press equals. Okay, so now we've got this table. Okay, I want to go back and I want to just share my next screen with you, and then bring my calculator back and share both of them with you. Complicated stuff. No, I'm just kidding. So now we can see that in cos, let me get a pen, Between negative 180 and negative 90, we can see that the answers are negative. So I can put a negative sign here as well. Then if I scroll down my table, between negative 90 and 0, my answers are positive. So here I can write a plus. Then if I scroll down my table some more, between 0 and 90, my answers are also all pluses. So we can do that there. Then between 90 and 180, let's go take a look. We can see that it's all negative. Yes, my table is unlimited. So this means that I can do this exercise for a smaller step as I want and for as many values as I would like to as well. Okay, so between 180 and 270, you can see it's negative again. So we'll just type in negative. And then between 270 and 360, we can see that it is positive. So we'll have positive here. Right, so from this, I'm hoping that I won't lose my, you know what I did the last time, so let me not. So from this, I'm actually just going to leave it there and we'll draw on the calculator. Pardon. Okay, so I'm going to draw over here on my cast diagram, and we can see from sine that it's negative between negative 180 and negative 90. So it's negative there, and sine is positive between 0 and 90. So sine is positive there, and it's positive between 90 and 180, which is there. If I look at my cos graph, my cos is positive between 0 and negative 90, which is this angle here, right? And it is positive here, where it is between 0 and 90. And then again, it's positive between 270 and 360, which we've already written down. Now, if we did the tan graph, we would see that it is positive here and negative in the 90 to 180, positive between 180 and 270, and negative between 270 and 360. So here we can see that all of them are positive. Only sine is positive, only tan is positive, and only cos is positive. And that is actually where the cast diagram comes from. Okay, so the question is, you are on grad and how do you get its degrees? And I'm going to come back to that question when we do the conversions. Okay, cool. So let me just clear all the pictures here, and then we can move on to the next thing. So now we can talk about solving trig equations. All right, and you obviously use our cos graph, and you know all the basic steps. So I'm not going to go through this with you now. What I do want to show you is how to deal with a specific solution. So we solve this whole thing, and we're looking for values between 30 degrees and 200 degrees. And we have two general equations here, negative 10.53 plus K360, and x is equal to 130.53 plus K360. So what we're going to do is on our calculator, in our table mode, we're actually going to substitute. Let me just share so you can see the equations. So what we're going to do is actually substitute our general solution into our two functions. So here I'll have negative 10.53 plus k is now, we obviously don't have a k, so we'll use an x instead, times 360. And in function 2, we'll have 130.53 plus, and again, we have an x instead of k, times 360. Okay, so now let's start at 0 this time and make our steps. 1, because k is an integer. So we're looking at just the basic values, negative 1, 0, 1, 2, that we can substitute in for k or x. So here we can see we're looking for values between 30 degrees and 200 degrees. So if I look at my table, my first solution is negative 10. So that's not going to work. My next solution is 130.53, which is between 30 and 200. And if I look at my next solution is 349, which is too big. So I can already see from my substitutions that the only specific solution available to us is actually that 130.53. So it's a really nice way to do the substitution without all of that extra confusion, and you know that the ease with which students make mistakes when we talk about these substitutions. Are we all good with trig? Can I move on to conversions? Okay. If you do have questions, just chuck them in the chat and let me know, and we'll talk about this. Okay, so Anna, this is going to fix your problem with the grade. Okay, so when we have polar and rectangular coordinates, which is both in AP Maths and in technical maths, I'm going to actually press my home button, and home just takes me back to normal mode from whatever mode I was in. Okay, so you can see here your calculator is as a standard set to degrees. If you want to reset your calculator, on the back of the calculator is a little button, a little black button with the word reset next to it. It's just underneath your battery description. And that's imprinted into the back of your calculator. So you would just press that with the tip of your button, of your pen. Now, obviously, sometimes you just want to fix one thing and you don't want to reset your entire calculator. So to change into degrees, you can use setup, so second function math, and then you can choose 0 for DRG, and you can see what degrees, radians, and gradients. And if we want degrees, we would just say 0, set it up like that. Now, there is a really nice shortcut, which is over here. So say, for example, we have 30 degrees and we want to convert them into radians. What we would then do is say second function and our decimal, and it will now convert 30 degrees into radians. Now we are working in radians. So if, for example, I have, Mwandi, if you have a question, just pop it into the chat for me, okay? So if I have, for example, 4 pi over 3, right? And I want to convert this now into degrees, I can then say second function and the decimal, and then second function and the decimal again. So it just loops between degrees, radians, and gradients. So 4 pi over 3 is 240 degrees. Now, again, this is where your D keys come in handy. So if we're doing a lot of these, we can actually store into our D2 key, for example, the second function DRG button. So now when we want to do lots of quick conversions, let's say we have 90 degrees and we want to convert to radians, we can just press our D2 key and it will come up for us instead. Mwandi, so I hope this answered your question, because this is how we change from degrees to radians. Okay, and this should also have answered your question as well. Awesome. Okay, so from there, let me go back here so that I know in which direction I want to go. We can also convert hours to minutes and seconds. So I'm going to bring back my calculator. Let's say, for example, we have 36 hours and we want to know how many minutes that would be. We would just press math, and then we would say, okay, I want it in minutes, so that's option 2. So we just press 2, and then we get 2,160 minutes. If you want to go from minutes to hours, a little bit different. What you do is use 0 as a placeholder, press your DMS button, and then type in 2,160, right? That was the same thing, and then press equals, and you'll see now we get 36 hours. So that's just the reverse of that function as well. Now, there was also, for the technical maths, conversion between different mensuration units. So we talk about inches and centimeters, meters to kilometers and all of that. But it's nice to know that you can also do all of these various conversions like ounces to grams. So let me just show you quickly. So if you enjoy baking, this is very handy to know. You can convert English recipes or American recipes actually into metric units. So say, for example, we have 36 ounces and we want to convert those into grams. what we would then say is alpha, and you'll see number 5 has a little convert. So we press 5, and we're looking for ounces to grams. So we just go through our table and look for ounces to grams, which is 13. You have, if I recall, 44 different conversions that you can use. So it's really nice to have, these are particularly nice for the science students as well. So let me just go back up. We said it was 13. So you'll type in 13, and there we go, and press equals. And now 36 ounces is 1,020 grams. So it's basically actually a kilogram. So that's the conversions unit for you. Now we can also do binary. So again, this is for technical maths. So if we wanted to convert any number to binary, what we would do is say we have 235, and we would then press second function and our divide button, and that would then give us the binary calculation. Now you can do any binary calculations here on the calculator. So you've got plus, minus, times, divide. You can also use your not, and, or not, or all of those logic keys, but we don't use them in technical maths. They are more used for programming. So that's just a heads up. So once we are done, we can then convert it back into decimal by saying second function and your equals button. You'll see in orange it says decimal, and then that will give us back the correct answer. Now see, I'm in radians, so let me just change back to degrees as well. All right. Happy so far? Can I move on to calculus? Real good. Okay, cool. So the first thing is you can do a derivative at a point on the calculator. It is possible. You cannot get the algebraic solution because it's a calculator. It doesn't do that. But it is nice if you want to just check that you're on the right track. So what you do is you press alpha and your close bracket button. You can see there's ddx, and then you just type in whatever your equation or expression was, and you just press RCL to make an x, and then you would set a value. So what is the derivative when x is equal to -1? And we say equals, and it will give us this calculation as well. So that's a differentiation at a point. It's nice to have just from a checking point of view. And then what we can also do is do calculus where we look at the table with the graphs. So I want to just share both of these so you can see my equation. What we're going to do is again go to table mode. And so we'll press mode and 2, and we'll type in this equation, this x cubed, plus 3x squared plus 34x minus 48. So we would have x cubed. So an x is just RCL twice. Then it's y to the power of 3. And then to the right arrow key, plus 13 RCL twice x squared plus 34 RCL twice minus 48. Now we've plugged in this whole equation. We're going to just skip through, and we've got start and step, which we'll leave as is. And what we're doing is we're looking for where we have a factor. So when x is equal to 1, we have the answer is 0. So we can see that x minus 1 would be a factor of this. And we can then again scroll through the table, and we can see as we're going higher and higher that none of the values work. So they're just increasing. Doesn't look like it's going to come back to 0. On this side, we can see there's a decrease, but then it's also coming back up again. So we should hit a 0 at x is equal to minus x. Our factor would be x plus 6. And if I scroll some more, I can see x is equal to minus 8. So my last factor is x plus 8. What's really nice is because your table is unlimited in either direction. So even though we started this calculation at 0, and our step is 1, we can go wherever we like, and we won't be restricted by the settings we put into the calculator, which is really nice. So from here, what we could do is, I want to put into function 2 the derivative of my original calculus graph. Okay, so I'm going to do that quickly and share both screens so you can see. So I'm going to press on once, which gives me my original graph, and I'm going to leave it there. And in function 2, I'm going to put my gradient. So 3x squared plus 20, oopsie, this is where BS comes in, 26x plus 34. Okay, so that's the derivative of our original calculus graph. We can say equals, equals, equals. Now, when we look here, this is telling me the size of my gradient at that point. So in other words, if I scroll up, I can see that my gradient is just steadily increasing. This is 239 over 1. So it's a very steep graph at this point. Whereas if I scroll up here and I look at the negative side of it, you can see here it has been inversed. What's the word? That's not the right word. It's changed its sign. So there is a stationary point somewhere between -1 and -2. And if I scroll some more, I should be able to find my second stationary point, which I can see is somewhere between -7 and -8. So if we want to draw the graph, we can see from here that the graph is really steep originally, right? So it looks like this, then it's going to hit -8 where it's a 0. It's going to peak, turn somewhere, and then over between, so there's -8 and there's -7, sorry, -6. So the peak is at somewhere between -8 and -7, and then it comes down again and it hits -6 through the through your Cartesian plane. So let's do it like that. And then it will again drop and then come back up and be really steep. Now, I know it's not a beautiful graph that I've drawn, but you can see that we can see what shape the graph should take from our coordinates. So if I'm looking between -1 and -2 is where this point is going to turn, and my last point where x is equal to 0, sorry, there it is at x is equal to 1. So it's over there. So it's quite easy to plot the graph once you have both of these, and you can see exactly where your turns are, or approximately where your stationary points are, because with this one we'd have to use the quadratic formula to solve it, which I'll get to in a little bit as well. All right, then of course the age-old story of integration. Now, you can do integration on the calculator, but it is between 2 points. It's not an indefinite integral. So I'll just show you a quick example here. So we're going to go back home again. Say home, and then we're going to say alpha and your open bracket button. You'll see above it in green, or in alpha in teal, is your integral. So you'd start with the bottom, so we can say -pi, for example. And then if we just use our arrow keys to shift our cursor, we can have pi. And I should really have this set up in, sorry, I should have this set up in degrees, radians, if I want to use pi as my integral, but there we go. So now I can say -pi and pi and sine x and equals, and it's a very tiny value, so it's very close to 0. Or we could have sine squared m, sorry, that's not it, just put it in brackets. Wow, there we go. Okay, and then square it, and we would say equals, and we'd also get pi. So it's very nice to be able to see exactly if we wanted to check our solutions, particularly for integrals where we are checking these sorts of solutions. Okay, so that's integration. I'm going to move on to complex numbers. Is everyone still good? Happy? Okay, fantastic. So I did start this year with one student doing AP maths, which I'm loving. It's so interesting. It makes a nice change from just normal maths. So it's really nice to be able to use that maths again. But one of the things that she really struggled with in the beginning was the core concept of what I is. So to demonstrate this to her, I used the calculator, and in normal mode, I said to her, okay, if I took the square root of -1, what would happen? And we would get an error, because when we deal with the square root of -1, and we're taught this all the way through, is that you cannot take the square root of a negative number. It's impossible. It's called a non-real number. Okay. But when we move into complex mode, so we start thinking about these non-real numbers as complex numbers, and we then take the square root of -1, we can see that it then gives us this value of I. And if I used I and I squared it, squared it, it should then give me -1, because we're just cancelling out the square roots and the square to give us the inside of the bracket, which is -1. So it's a nice way to just walk through that with your students. I know it's a bit late now in the year for the grade 10s, but for next year, it's definitely an interesting thing. Then to input any complex numbers into your calculator, so you can see if you look at the DMS button underneath it, it's just got a little I. So this I will only work in complex mode. So if I wanted to say 3 plus 4i, like so, then we could do it like that. Or if we were doing the proof where we add the conjugates together, like so, we would get just like that. Okay, so it's really easy to put the complex numbers in as well. Now, for more towards the technical maths guys, you can also convert between your complex numbers and your argand diagram, where we talk about your arguments and your angle. So here, if I put in 3 plus 4i, oopsie, I. Now you can see in my left-hand corner that it's an XY brackets. Okay, sorry, just an XY, which is telling you that currently speaking, these coordinates are given to you as rectangular coordinates. If I wanted to convert them into polar coordinates, I would simply press second function and my 8 button, like we did for that Pythagoras shortcut. And you'll then see that you've got your R, or your argument, which is 5, and the angle, but now we're measuring it in radians. So again, if we wanted to convert that, we'd have to first see. It doesn't like that. Let's just do it this way. So now if we wanted to convert, let's do it again. So if I have 3 plus 4i, keep doing that, right? And then I converted it into polar coordinates. You can now see that this is my degrees angle instead of my radians. Okay, so just be aware of whatever you're doing your stuff in, whatever units you're using when you are using your calculator as well. Make sure it's set to the correct units as well. Then, of course, you can go back again. So we could, for example, type in your argument and your angle and convert it back into polar. And you'll see above XY in orange is a little angle sign. So if our argument is 7, we'd say second function and that button to give us this. And then we would type in, say, an angle of 30. Okay, and now if we wanted to convert it, I'm just pressing equals so you can see. You don't have to press equals. You can just do it straight like that. And it would then give you that as well. So you can enter it both ways. So if I've got an argument with an angle, I don't even have to change my settings. I can just type it in vice versa and have it set up already for me. Okay, So those are some nice handy things in complex mode. Of course, you do have access to a conjugate. I don't honestly see the point because it's pretty straightforward. It's just the negative, and just change the sign of the complex letter or the complex value of I. But it is nice to know that you can do it on the calculator if you're really stuck. And of course, you can have your argument and your real value and your imaginary value given to you as well. So those are all of those things as well. Okay. Questions? Are we all good so far? Shall I jump into absolute value graphs? So what's really cool here. Oh, hi, Melson. Thanks for joining us. Sorry it took so long. I know internet is frustrating. Okay, so let's talk through this absolute value graph. And what's really nice here is you can talk up through the shift of the graph as well. I just want to add everything. So this is a grade 10 version of the graph. So we're going to go to mode and to the table. And you'll see your absolute is here on this negative value. So you just say second function and absolute, and then you make your x like so, and then plus 3. And then we can talk about the shift. So for example, if I did the same graph, but I now I subtracted 2 inside of that absolute value and then added 3. So this is my P shift. What is going to happen is I'm going to see that I'm adding 2 every time. And as I go, in fact, it gets smaller and smaller. And then from this side, it gets bigger and bigger, depending on the direction. So it's quite a nice way to demonstrate the difference between everything that's going on with the calculator as well. You can see that they have the same value when x is equal to 1, which is really cool. All right, so that's just a basic jump into absolute value graphs. Again, it's really up to you how you teach them. There are some really nice ways to teach graphs using the calculator, where they just draw basic graphs and explore what happens if they change one thing on the graph, and so on. So present value annuities. Is everyone happy? We still all good? Okay, so I am gonna share both my calculator and screen with you again. And again, we're gonna work in table mode. So to clear the function away, I'm just gonna press on twice. And I'm actually gonna input this present value annuity. And what I'm doing is I'm looking for how much I can pay and how much I could pay monthly for 5 years. At an interest rate of 10%, if I borrowed a certain amount, or if I was willing to pay back 100 Rand, how much could I borrow? If I paid it back over 5 years at a 10% interest rate. So that's basically what we're talking about here. So I'm going to just press RCL twice to make my X, and then just type in this whole long thing here. So 1 minus, and you can do this with future values as well if you wanted to. So 100. Oh, and then of course it's compounded monthly, so that's where that times 12 is. Close your brackets to the power of -5 again, and we're paying it monthly, so it's compounded. It's times 12. Close the brackets, and then over your interest rate, which is 10 over 100 times 12. Okay, so it's a long. I know I did this really fast. I have practiced. So it's a really long formula, but once you get the hang of typing into the calculator, it really becomes quite intuitive. And all of this is here on the calculator for you. So what we're going to do now is I'm just going to share my calculator with you so you can see it quite nice and big. And then I'm just going to delete function 2 by just clearing it and pressing on. And then again, let's make our start 0 and our step 1, and we'll just go through this. So basically what this table is telling you is if I was willing to pay back 1 Rand a month for the next 5 years at an interest rate of 10% per annum compounded monthly, I could borrow 47 Rand. And if I was willing to pay back 10 Rand a month over 5 years at a 10% interest rate, I could borrow 470 Rand. Now, this doesn't really help us in terms of actually looking at affordability. So what I want to do then is actually change my step, and I'm going to make my steps 100 instead. Okay. So here we'll see that if I'm willing to pay back 100 Rand a month, we can borrow 4,700 Rand. Now, if I'm purchasing a car and my affordability is 1,000 Rand and I know my interest rate is 10% for 5 years, I can borrow 47,000 Rand. And so on and so forth. So if I wanted to buy a car for 100,000 Rand, my approximate payments would be 2,200 Rand. Now, what's cool is you can go back to your table, and let's say, for example, your interest rate now changes to 9.5%, and we take out the loan over 6 years instead of over 5 years. So I'm just basically editing my formula here, right? And equals. Now, if I can pay back 1,000 Rand, because I'm paying it over a longer period of time, I can actually borrow 54,700 Rand. Or if I wanted to borrow 100,000 Rand over 6 years at 9.5%, it would cost me 1,900 Rand. So that's actually a difference, or between 1,800 and 1,900 Rand, which is a difference of 300 Rand a month. So it does show you the affordability based on your different interest rates and number of years and periods and so on and so forth. What's really great is you can put, say for example, you know that you can only afford 1,000 Rand, right, a month. So what we could do here is, oh, I did this the wrong way, I should have. Anyway, I'll teach you the shortcut after this. Let's say I have 1,000 Rand. Okay, and now I want to know how much I can borrow if the interest rate changes. So here I'm just going to change my interest rate to X and put this all in here. And again, at 6 years, I'm just going to leave it at 6 years for now. And obviously now my interest rate is in steps of 1 or half. So I'll leave the start at 0, but I'll make my steps at 0.5 or half. And now you can see that at over 6 years, if my interest rate is 0.5%, I can borrow 71,000 Rand. If my interest rate is 5%, I can borrow 62,000 Rand over 6 years. So we can also look at a house, for example. So a house would be over 20 years. Okay, so I'm paying 1,000 Rand a month over 20 years, and I want to see what effect my interest rate would have. So here, if my interest rate is 5% per annum compounded monthly, I can then buy a house at 151,000 Rand if I'm willing to pay 1,000 Rand a month. So it's really very interesting to be able to just adjust your formula slightly and look at the difference that it makes, the difference that interest makes, or the difference that your monthly repayments make. Or you could even put it in as your number of years. So here I could put in, let's make my interest, let's call it 8%. And here we'll make it in X. So my interest is also 8%. And then if I press second function and left, it will take me right to the front of the graph, which is what I should have done. And let's make our monthly repayments 3,000 Rand. Okay, so if we're paying back a home loan over 20 years at an interest rate of 8% per annum, then if I pay it back over, let's just talk about years here. So now X is our number of years. If I'm only willing to spend 1 year, I can borrow 34,000 Rand. If I'm willing to pay back it over 5 years, I can borrow 147. If I wanted to pay back over 20 years, I could borrow 358,000 Rand. So you can see it's a really nice way to play around with both your present value and your future value annuities, just by adjusting different things using your table mode. And it's, as long as you keep it all square in your head, it really is such a nice way to talk through present value annuities with your students. So I hope I haven't gone too complicated on this with you. Thank you, Nansalela. Yeah, but it's really such an amazing feature, especially the table mode. There's so many incredible things you can do just with teaching students different concepts and exploring those concepts and making them intuitive. Okay, I'll jump off my excited present value horse here. So let's talk through, are there any questions with regards to present values? Because I went quite on a thank you, Melson. I went on quite a long tangent there. So are we all good and happy? Okay, fabulous. All right. So let's talk matrices. Now I see for AP Maths in grade 10, they need to do a 2 by 2. And then grade 11 is a 2 by 2. And then grade 12, we look at a 3 by 3 and then a 4 by 4. So the good news is your calculator goes up to from 1 by 1 to 4 by 4. And so what I'm going to do is I just want to show you, I'm actually not going to use this example. I'm going to use a 2 by 2 matrix because it seems to be the most relevant to everybody. So we're going to press mode, and then we need 5 for matrix. And to input a matrix, what you would do is press math, and you would press 1 for edit. And you can see standard, it comes up as a 2 by 2. So if you wanted to change anything, you can just go back like that. So it's quite easy. Once you're happy with your dimensions of your matrix, you can then just press equals. Then when you type in your matrix, it obviously goes left to right and then top to bottom, like you're reading. So if our values are 2 and -5 and 7 and 8, right? Okay, so once we've typed in all our values, obviously you press equals after each value. We now want to store the matrix into the calculator. So to do that, we just again press math and 3 for store, and we can just choose matrix A. Okay, now let me show you the long way first. So if I wanted to now work with that matrix that I've stored, I would press math, I would choose 0 for matrix, and then again we used matrix A, so I would press 0 again. Now if I wanted to do a scalar multiplication, I would just say times 3 is equal to, and then it will give us this matrix. Okay, now what I can do then is I've got to press on. Now that matrix has now been edited, so I can then store that second matrix into matrix B. If I wanted to multiply matrix A with matrix B, well, the long way around is to say math matrix A times math matrix and then matrix B, and then say equals, and that will give us that finished matrix, right? So the short version is, remember your D1, D2, D3 keys. So if you're working with matrices a lot, what you can then do is store the name of the matrix into your D1, D2, D3 keys. So you can press math, choose 0 for matrix and 0 for matrix A. Now, if I wanted to find the square of matrix A, instead of having to say math 0, 0, I can now just press D1 and it will automatically come up. And then I can square it and say equals, and it will give me this. In other words, matrix A times matrix. If I wanted the inverse of matrix A, then I could say D1, and my inverse is just x to the -1. So second function and this button here, and equals, and it will give you the inverse there for you. Okay, so nice and quick and easy, instead of having to do that a translation. And what's great is you can do this inverse for as big as a matrix as you, well, up to a 4 by 4 matrix. Of course, if you wanted the determinant as well, so to get the determinant, we would say math first. Determinant is number 4, so we just press 4, and then of course give the name of the matrix A and equals, and we get 51. So it's really easy to use your calculator to do these matrices calculations. Okay, so this is a long, hectic example, but again, it is a good idea to go and play with the calculator with the matrices and see what you can do. So this is the same example that I went through where we stored the name of the matrix A and then we squared it. It's just got a different matrix saved. And then of course the inverse. So you can see even with the 3 by 3 matrix, your inverse values are there for you as well. Determinants and the transpose as well, if we wanted to do that, just very quickly, although it's pretty standard, it's good to know. So if you press math and 5 for transpose and then determinants, and then the name of your matrix and equals, you would see that it's now switched the rows and columns around as well. Now, I was telling a teacher about the row echelon form because it's such a pain to actually do. So you can do it. I think, well, let's just do it with the 2 by 2. So what we're going to do is, to get to row echelon form, you need to just say math first, press your down arrow key, and you'll see REF, which is row echelon form, and then B is reduced row echelon form. So that's if your matrix is not, I want to say symmetrical, but that's not quite what I was looking for. But it's not a 2 by 2 or 3 by 3 or 4 by 4. It's a 2 by 3 or 3 by 2, and then that affects that. So if we use A, so that's just using your A memory key, and then the name of your matrix, and you'll see now, of course, the diagonal ones and that. So when you want to solve a matrix, then that's a nice way that will definitely help you with that as well. So again, we can do this, but I don't think it's necessary. Well, actually, let's just do it and why not? So let me I just want to share both screens so that we can copy the example. So here's my matrix. All right. So again, we're going to edit a matrix and we're going to have a, wrong way around, a 2 by 3 matrix, right? Okay. Then in the first row, we've got 3, 6, and -2. Again, remember to use your negative button. And in the second row, we've got 1 and 7 and 8. Okay, and then we'll store this into matrix B. So we're going to say clear away our working because we can't store while the matrix is actually on the screen. So you'd say on, and then say math, choose 3, we'll store, and we'll store it into matrix B. Okay, then to get the reduced row echelon form, we would say math, press our down arrow key, and we got B. So again, we use that memory key B, which is the square root button. So reduced row echelon form. And then we would call our matrix B, which we didn't save into our D keys, unfortunately. So we'll go the long way around. And then we would say equals. And you can see you've got your 1 and 0, so your identity matrix, and then the solution of X and Y. Or if you could do a 3 by 4, you would have a solution of X, Y, and Z as well. Okay, any questions there? Are we good with matrices? Now, I did see that logs come up more in the AP maths and the technical maths side of things, and a tiny little bit in grade 12 maths. So I did want to just show you the math side of just quickly how to input logs. So you'll see on your pi button, there's an orange log with the base A and X, and over here is a regular log. So this is log base 10, right? And then if you wanted a log with a different base, you would say second function in pi, and then fill in your base first, and then of course your value, and you would get your answer, your exponent. So this is nice for teaching rules. So for example, we can see that log base 2, and let's put a 4 in there, will give us 6, which is the same as saying log base 2, 8 times 4. Oopsie. Why did that give us 6? That doesn't. having a moment here. Oh, I think we're supposed to add it, right? Plus 4. No, that also doesn't. Okay, I'm going to come back to that because that should have done exactly the same thing according to the rule. So that's weird, but I'll check on that as well and just see. Okay, so equation mode. Yeah. Anyway, let's talk through solving equations very quickly. So we've got an equation mode. So we're going to say mode and for equation. And you'll see you've got a 2-variable linear equation, a 3-variable linear equation, a quadratic, and a cubic. So remember, linear means x plus y with no squares on them. So they're nice for solving simultaneous equations or straight line equations. So if we did, for example, the cubic, if our a was 1 and our b was 17 and our c was -3 and our d was 9, I'm just making this up, you can see that it would give you 1x, which is the whole a real answer, and then you've got your complex answer as well. So that's just the equation mode. What I do want to come back to is the quadratic formula and how easy it is to use the calculator for that. So and this is nice because it's relevant to both the math students and the AP maths and the Trig. Okay, so we're going to go home again. Now we have an expression here which is 3x squared minus 51x plus 17. So what we're going to do is we're going to take our a, b, and c values, so that's 3 minus 51 and 17, and store them into the memory keys of our calculator. So we're going to have 3 and we're going to store it into a, -51 and store that into b, and 17 and store that into c. Okay, then what we would do is we would type in our x is equal to quadratic formula. So we'd have negative, and then to make a b we say alpha and our memory button. Plus or minus, obviously we can't do a plus or minus on the calculator, so you can either start with plus or with minus, that's up to you. And then square root, and then we have alpha b squared minus 4 alpha a and alpha c over 2 and then alpha a as well. Okay, so that's our quadratic formula typed into the calculator. If we press equals now, it's going to give us a solution to x. To find the other solution, you can press your left arrow key once and then press second function left to go right to the front of the equation, and then to just change that plus to minus, we can say backspace and then add a minus and say equals, and it will give us our other solution there. Now, what's really great is the time saving that this now affords you. So for example, if I now stored different values into A, B, and C, right? And I then went back up to my expression. Oopsie, I've stored the wrong value somewhere. Let's see if that works. There we go. So then that would give us our new answer. And again, we can just shortcut and go back to the plus and get our new solution as well. So there's our two solutions, the completely different quadratic formula that was really easy and quick to change. What's also really nice here is you can see what's saved into your memory keys. By pressing alpha and 9, you'll see above 9 it says memory. So you'll see all of your memory keys are there and you can see exactly what's been saved. So you can see 20 in your X and Y is 57.52. That comes from your, when you did the polar and rectangular coordinates. So it will just say the last thing that was in there as well. Okay, awesome. That is everything that I was going to cover tonight. Are there any questions or thoughts or suggestions? While you're thinking about those, to those of you who watched us on YouTube, thank you so much for joining us. I hope that you found this valuable. Please like and share our YouTube videos and spread the word. And then don't forget to visit maths@sharp.co.za for both the free simulator as well as for the free worksheets from grade 8 to 12.